All right, welcome to The Explainer. Today, we are diving headfirst into what is honestly one of modern astronomy's greatest detective stories, a hunt for invisible giants lurking right here in our own cosmic backyard. So here it is, the central mystery we're tackling today. We're not just looking for any old black hole. Nope, we're on the hunt for the ones that are locked in a gravitational dance with a star, the invisible companions hiding among billions and billions of others.
To even begin to answer this question, astronomers have to put on their detective hats. They're piecing together these tiny, subtle clues to find these hidden ghosts in our galaxy. So our investigation starts right now.
Okay, so first things first, we have got to get rid of this old idea that black holes are some kind of super rare cosmic oddity. They're not. They are a fundamental, almost common part of the Milky Way's whole structure. Let's talk about just how common they really are. All right, just like any good detective story, before you can find your suspect, you need a profile, right? We need to know exactly what we're looking for. What kind of star even becomes a black hole? Where do they come from? So our cosmic crime scene? It's the entire Milky Way galaxy. We're talking about a place that is just teeming with somewhere between 200 and 400 billion stars. I mean, that's an almost unimaginable number of places for our targets to hide. But here's the thing. Only a tiny, tiny fraction of all those stars are actually candidates. We're on the lookout for the real heavyweights of the cosmos, stars that start their lives at more than, say, 20 to 25 times the mass of our own sun. It's only those giants that have enough gravitational muscle to collapse down into what we call a stellar mass black hole when they die. So when you run the numbers, what you find is pretty staggering. Our galaxy isn't just home to a handful of these things. We're looking at a massive suspect pool of around 100 million black holes. Seriously, 100 million. Okay, now here comes the real twist in our story. We know there are millions of these black holes out there, but the question is, how many of them aren't flying solo? How many are locked in a cosmic partnership with a companion star? And you know what's crazy? The odds actually start out pretty high. It turns out that over 2/3, more than 70% of the kinds of massive stars that are destined to become black holes are born with a partner. They start out as a pair. But here's the catch. The birth of a black hole is anything but gentle. It's a ridiculously catastrophic event. A supernova explosion that can easily, and I mean easily, just blast its partner away, tearing the whole system apart for good. So whether a pair actually manages to stay together through all that cosmic violence, well, it all comes down to this really delicate balance of forces. You've got to consider things like the sheer velocity of the kick from that supernova explosion, how much mass gets blown away, how far apart the stars were to begin with. It's a really, really tough environment for any partnership to survive. So against all odds, some of these pairs do survive. So let's shift gears and look at the evidence. How did astronomers develop the tools to actually hunt for these gravitational ghosts, these invisible partners that we know are out there? For the longest time, the only real clue we had came from X-rays. See, in some of these systems, the black hole is actively siphoning gas off its companion star. And as that gas gets pulled in, it heats up and glows incredibly brightly in X-rays. For astronomers, this was the smoking gun, clear evidence of a black hole at work.
But this method pointed to a huge problem. These active, feeding black holes, they're actually pretty rare. Most of them are what we call dormant. They're just sitting there, completely dark. Which meant that the X-ray binaries we could see were, just as this quote says, only the visible tip of a vast, hidden population, an enormous, invisible iceberg.
So that became the real challenge, right? How in the world do you find the silent majority? The ones that are just quietly orbiting their stars, giving off no light, no X-rays, nothing at all. Well, the breakthrough, the absolute game changer, was a new technique called the astrometric method. It was made possible by incredible missions like the Gaia Space Observatory. The idea is brilliant. You track a star's movement with unbelievable precision, and you look for a tiny, subtle wobble. A wobble that can only be explained by the gravitational tug of an unseen, really massive companion, a black hole. And guess what? It totally works. The discovery of a system called Gaia BH1, which happens to be the closest known black hole to Earth, was our star witness, if you will. It proved without a doubt that these dormant systems exist. And even more fascinating, it showed that some of them can form pretty quietly, maybe without that super violent supernova that we thought would always destroy the partnership.
Okay, so with these new clues in hand and these new ways of detecting the invisible, we can finally start to build our case and get really close to answering our big question. So, what's the final count?
Now, to get a number you can really trust, astronomers don't just rely on one piece of evidence. That would be too simple. Instead, they combine everything. They take the direct observations from missions like Gaia. They run these powerful computer simulations of how stars evolve in pairs. And they even pull in clues from a totally different source, the gravitational waves detected by experiments like LIGO.
And what these models tell us is, well, they give us a range. The standard simulations, the ones we've used for a while, they predict somewhere between 50,000 and maybe 500,000 of these systems in the Milky Way. But, and this is a big but, if that quiet collapse that we saw with Gaia BH1 turns out to be common, then that number could shoot way up. We could be talking about over 1 million.
So here it is, the verdict from all of this cosmic detective work. Our own galaxy is likely home to somewhere between 50,000 and potentially more than 1 million hidden pairs of a star orbiting a black hole. But you know, the really interesting thing here isn't just that big number. What's truly profound is how this discovery completely changes our picture of the galaxy. We've gone from thinking of black holes as these rare, bizarre monsters to understanding that they are common, almost ordinary citizens of the cosmos. What we're really uncovering here is an entire unseen structure within our galaxy, a hidden population of objects that interact pretty much only through gravity. It's like we're discovering a shadow ecosystem that has been shaping the universe in ways we are only just beginning to grasp. And all of this leaves us with one final, kind of mind-blowing thought. The next time you're outside on a clear night and you look up at the sky, just remember that many of those familiar twinkling points of light might not be alone. Any one of them could be hiding a secret companion, an invisible dance partner, just waiting for us to find it.